Let x have a binomial distribution with density function of x sub x with parameter in P, then the function of x minus 1 sub x with parameter in P is less than with the function of x with sub x with parameter in P. For every x less than the quantity of n plus 1 times P. The function of x minus 1 sub x with parameter in P is less than with the function of x sub x with parameter in P for x less than the quantity of n plus 1 times P, and the function of x minus 1 sub x with parameter in P is equal to the function of x sub x with parameter in P if x is equal to the quantity of n plus 1 times P, and n plus 1 times P is an any integer where x range over 1 up to n. So now, let's prove that the function of x with parameter in P sub x over the function of x minus 1 sub x with parameter in P is equal to n minus x plus 1 over x times the quantity of P over Q. Then is equal to 1 plus the quantity of n plus 1 times P minus x over xq. So let of f of x sub x with parameter in P over f of x minus 1 sub x with parameter in P is equal to, for f of x sub x is equal to nx. Then for the with parameter in P, p to the x times the q to the power n minus x over, for the function x minus 1, we have now n to the n x minus 1 times p to the power of x minus 1 times q to the power of n minus the quantity of x minus 1. So for nx is equal to n factorial over x factorial times the quantity of n minus x factorial over, for the function x minus 1, we have now n factorial over x minus 1 factorial times the quantity of n minus the quantity of x minus 1 factorial. So copy p to the x times q to the power of n minus x over p to the x minus 1 times q to the power of n, distribute negative times positive x is equal to negative x, negative times negative 1 is equal to positive 1. So n factorial over x factorial can be equal to x times x minus 1 factorial. So copy, we have now x times the quantity of x minus 1 factorial times n minus x factorial all over n factorial over x minus 1 factorial times n distributive property, negative times x is equal to negative x, negative times negative 1 is equal to positive 1 factorial. Then copy to p to the x times q to the power of n minus x over p to the power of x minus 1 times q to the power of n minus x plus 1. So we have now n factorial over x times x minus 1 factorial times the quantity of n minus x factorial all over n factorial over the x minus 1 factorial. Then n minus x plus 1 factorial can be equal to n minus x plus 1 times the n minus x factorial. So we have now, by law of exponent, p to the power of x minus the denominator, the exponent of the denominator, x minus 1, the quantity of x minus 1. So for the q to the power of n minus x minus the exponent of the denominator, we have now minus n minus x plus 1. So by the law of division of fraction, copy the numerator, then multiply the reciprocal of denominator. So we have now n factorial over x times the quantity of x minus 1 factorial times the quantity of n minus x factorial. Multiply the reciprocal, x minus 1 factorial times n minus x plus 1 times the quantity of n minus x factorial all over n factorial. By the law of exponent, p distributive property, p to the power of x minus x, negative times negative 1, positive 1. So times the quantity q to the power of n minus x, negative times negative positive n is equal to negative n, negative times negative x is equal to positive x, negative times positive 1 is equal to negative 1. So n factorial cancelled out, x minus 1 factorial cancelled, n minus x factorial cancelled, then n factorial cancelled. So we have now n minus x plus 1 over x times p to the power of x minus x equal to 0. So we have now p to the power of 1, n minus n is equal to 0, negative x plus x equal to 0. So we have q to the power of 1, n minus x plus 1 over x times, by the law of exponent, the negative exponent, we have the i-inverse daw nato ang 1 ay ang, for example, q to the power of negative 1 is equal to 1 over q. So times the p is equal to n minus x plus 1 over x times p over q equal to pn minus x plus xq plus p all over xq. So separate by terms is equal to pn over xq minus x over xq plus xq over xq can be equal to 1 plus p over xq. So we have now pn over xq minus x over xq plus 1 plus p over xq. So ipagawas na to ang constant, 1 plus pn over xq minus x over xq plus p over xq. So get the LCD of the three terms. So 1 plus the LCD of three terms is xq. So copy the numerator pn minus x plus p because the denominator is the same. So we have now combining the like terms, 1 plus pn plus p minus x over x cubed is equal to 1 plus factor out ang pn plus p. So we have now p times the n plus 1 minus x over x cubed. So we have the final answer 1 plus p minus x times the quantity of n plus 1 over x cubed. So that's end the theorem 4.